Hey guys, welcome back to the next video. In this one, we will be covering how to use acetals in a synthesis question. So what's the important part about acetals? We've been going through this new functional group. What is its value in some of the questions you'll be seeing other than, like let's say, some reaction where they ask you to use it. So acetals come up a lot in synthesis and they're very useful in synthesis. So let's take a look at this question right here. Basically, I've wrote out a synthesis scheme, and the question is this a good synthesis? Would you get full points on the exam if they asked you to synthesize that? So let's take a look step by step. We start out with a carbonyl that's got a bromine on the same compound. Now we want to add carbons eventually, so we put a lithium there. Turn the Br into a lithium. Now that we have our lithium, the carbon with the lithium is going to connect to the carbon of the double bonded O. 1, 2, 1, 2. And the double bonded O becomes an OH, and we added our carbon. Now, this synthesis may look perfectly fine, but there is one small problem. In this first step, when we added a lithium instead of the Br to replace the Br, we now have a lithium with a double bonded O compound. The problem with that is that, keep in mind, we have a bunch of this stuff floating around, not just one molecule in your little beaker. And so we have a bunch more of them. And what's going to happen the second we add that lithium, this lithium is going to see that carbonyl on another molecule like it, and it's going to attack instead on that spot, not the product we want. Instead, it's not going to attack the one I circled, but another one of itself. So in the end, we're not actually going to get this. We're going to get something different, and that's a problem. Now, acetals are the way to fix that problem. In Orgo 1, you learned of a different protecting group that protects alcohols. Acetals can protect carbonyls. So how would we fix the synthesis? So the first problem right here is the lithium. That's the big issue. So we have to sidestep that almost. So how do we sidestep it? So I'm going to rewrite this. Now I want to protect that carbonyl. I want to make sure that once I put that lithium on, it's not going to attack another carbonyl, not the one that I wanted, that I don't want it to attack at least. So this is how we use acetals. So what you're going to write on your arrow is this. You've seen this in the previous videos. That's called ethylene glycol, and it's a very simple acetal. And we write it with some form of acid like H+. That's the easiest one to do. What is this going to do? How is it going to look? You can just redraw your exact same compound like this. And at the double bonded O, what we're going to do, take note that there's 2 carbons here. All you're going to do is have an oxygen, 2 oxygens connected to that same carbon, and with those 2 carbons in the middle forming this bridge. That right there, all of this is that part. Now we don't have a carbonyl anymore. It's protected. So our carbonyl is protected. Now we can go on and do exactly what else we wanted to do. So I wanted to put a lithium here. This is now the lithium. And because there is no double bonded O, we don't have this problem anymore. I'm not going to get any errors in my synthesis. You're not going to lose points because there's no double bonded O for the lithium to attack. Now I can go ahead and do the reaction. And so it's still going to add. And we get this. And now the way we just get rid of our protecting group is we have to use acid with water. That's the key. So you can write on your arrow H plus with H2O, or you could have written H3O plus. Doesn't really matter as long as there's some form of water. And remember, once H3O plus gives up the H, gives up the proton, we get water anyway. But to keep it simple, because this is what you're probably used to, I'll keep it like this. And it removes the ethylene glycol. It removes that protecting group. You don't need to draw it anymore. And we get this. That's exactly what we intended, but we were able to fix this whole mistake of putting a lithium on a compound with a double bonded O. So that's how you know when to use an acetal protecting group. If you see at one point you get a lithium with a double bonded O compound, then we're going to want to use the acetal. All right, now let's try another question to sort of just practice what we just did. Okay. So I'll write it under here. And if at any point you guys want to pause it, just to try it out again, feel free to do so. So we are going to synthesize this compound. Now, if you want to try it on your own, feel free to do so. Feel free to pause it here. And we're going to do it from benzene. So you can start from benzene. But this is what we're going to synthesize. So how would we do this? Because we're using a benzene, this is going to involve some not Frito-Crafts, some electrophilic aromatic substitution reactions. And so it's best to go forward when you're doing this type of synthesis. So I'm going to start with my benzene. If you like working backwards, that's perfectly fine. You can do this working backwards. So I have to add 2 carbonyl chains to this benzene, and they are meta to each other. So I'm going to pick one at random. In this case, you could really start with either one of them. I'll just pick the bottom one. So it's 2 carbons, 1, 2, and a double bonded O. One, 2. And because this is a Frito-Crafts acylation, if you remember, it's AlCl3 we have to put. And that adds the compound. So far this shouldn't be anything new. And we get this. Great. Now we want to add this chain here. All right. Now, if you remember back from the EAS topic, we have this group, which is a meta director. However, it is a deactivating group. And it's going to make this benzene ring 2 deactivated for another Frito-Crafts reaction. So we can't just do another Frito-Crafts acylation and call it a day. We have to do something else. So here's a little workaround if you have this situation. Because we have the meta director, and I know I want to add carbon chains. Well, the way we do it in normal synthesis to add carbon chains is we need a lithium, an organolithium compound. And what we usually had before that is a bromine. So let's add a bromine, which is something we can do even if the ring is deactivated. And that's going to put that Br in the meta position. Now, like we kind of just said before, we want to turn this into a lithium, but it would create a lithium with a double bonded O compound. That's where I know, okay, gotta use the acetals. So let's protect this first. So we draw out this ethylene glycol with H plus. And it's going to protect our carbonyl like that. Now we don't need to worry about it. Now we can continue our synthesis like normal. So let's see what I want to do. I want to add a carbon chain that is 1, 2, 3, 4 carbons long. So let's see. So I'm going to draw 1, 2, 3, 4. Numbering is your friend. Now, oh, my bad. We didn't even add the lithium yet. So let's add the lithium first. So now we have our lithium. Now we can do what we were going to do. So we want a 4 carbon chain. And definitely use numbering to make sure that you're not losing any carbons by accident. Now remember, organolithiums react with carbonyl compounds. The carbon we are connecting to is number 1, so that carbon should have a double bonded O. And we got to number it. So step 1 and step 2 with some form of acid. And that is going to connect that carbon of the benzene with the lithium to that chain. But keep in mind that carbon with the carbonyl is now going to have an OH there, like this. Okay, we have this OH. We have to just make sure that we return it into a double bonded O, and we have to take this protecting group off. So first, let's turn it into a double bonded O compound. We can use PCC. And remember, PCC is one of our oxidizing agents. And it just turns it into a double bonded O. And the very last step, take off our protecting group with some acid and water. And now we are going to go right to there. This double bonded O is back to where it was. And that's how we use acetals in synthesis. Now there is one little caveat with them. Notice the way we take off the protecting group, the acetal protecting group, acid and water. What this means is if you have your acetal protecting group on, if at any point another reaction uses acid and water, what it's going to do is it will take off your protecting group. So you have to just be mindful of that. Otherwise, they may take off points. What I mean by that is, let's say in this instance over here, instead of, let's say, using H+, I write out water, as that's something you guys have been allowed to do. In that case, what's going to happen is it will add this compound on. It will still do this reaction. But in that protonation step, it's also going to take the protecting group off. And we would have ended up with this. Now, in this specific instance, that's perfectly fine because the lithium would have been removed in the first step. And that's why we number. It shows these as distinct steps. So in this case, it's perfectly fine. If you did this, we would have gotten rid of our lithium. And then if you had water, you could have gone right to here with your double bonded O already back. And then we could have just done PCC to get all the way back here. We would have skipped having to make a step purely devoted to removing the protecting group. So you can use it as a shortcut, but you can also inadvertently make a mistake if you're not careful about how to about using acid and water. So just be a little bit mindful of that to make sure you're not making any mistakes in your synthesis. But that is the general idea of how to use synthesis with acetals, and I will see you guys in the next video.